All right, folks, so let's do this extra practice packet, focusing on 1 through 25 for this video. We'll see how far I can get. We got a trinomial, so we're thinking diamond method of one sort or another. The leading coefficient is 1, so that's sweet. We're trying to multiply to 10 because that's your C value, and add to 11 because that's your B value in the middle there. So 1 and 10 work. So just shove those behind the variable, which is m in this case. So m plus 1 in parentheses is a factor times m plus 10. If you FOIL that together, it works out. I'm going to leave number 3 for you. Number 5, trying to multiply to 48 and add to negative 14. So your multiples, or factors rather, of 48 are right here. Now, because we're trying to multiply to a positive 48, either both pairs of numbers can be positive, or remember, both pairs of numbers could be negative, because maybe you were looking here and you're like, ooh, that adds to 14, but we're not trying to add to 14. We're trying to add to negative 14. And negative 6 times negative 8 is still positive 48, but it adds to negative 14. So those are your numbers for the diamond. Then shove those behind the variable k in your factored form. If you FOIL it together and multiply it together, it equals the original trinomial. Hip hip, hooray. Number 7, don't let this scare you. I know it's new, but we'll be all right. I'm going to proceed like it's not even there. We're trying to multiply to 100 and add to 20. So that's 10 and 10. So we might be thinking originally x plus 10. Notice I left a little space there. Times x plus 10. But if you FOIL this together, it's not going to be right, because your last term times your last term is 10 times 10, which is 100, and it's supposed to be 100y squared. So guess, oh no, come back. Guess what? If you put a y next to each of those, then you get that 100y squared. And if you do the smiley face check, you get 10xy. 10y times x is 10xy, plus the outer smiley or bigger smiley face is also 10xy. Those are still like terms. That makes 20xy. You probably get the gist for number 9 there. Try that. Number 11, there's only 2 terms. That's because, folks, you could also write this as, back to number 7, folks. Notice our factors are exactly the same. When we do that, or when that happens, we should really write it as that factor times itself, or squared. Squared is the best answer. Back to number 11, shiny things. You could write this like this. It's equivalent. There are 0 r's. There's no r's. There's 0 r's. They didn't list that. So you could factor this with a diamond, thinking I'm trying to multiply to negative 9 and add to 0. Or you could do the difference of squares technique. And the difference of squares technique is nice because it's not always that doable with a diamond. Sometimes things get a little messy, especially if you have a leading coefficient. And sometimes squares, perfect squares, are massive. In fact, there's only a few small ones. So you can go this way if you remember that there's 0 of the middle term, or you can square root each of the terms in that binomial, and then the square root of the first term goes first, the square root of the second term goes second. And if you look at your factor chart, one of them has to be positive and one of them has to be negative. And when you solve the diamond, you hopefully realize that negative 3 times 3 is negative 9, and it adds to 0. So there's the right pair there.